In first theory, continental drift theory, what we have learned, the continents are drifting in horizontal direction. Continents are drifting in horizontal direction. But what Wegener mentioned there, Sial freely floats over Saimaa. That is, continental crust freely flows over oceanic crust. This created confusion because this was not true. The oceanic crust, there cannot be free movement of continental crust with oceanic crust. Later on, it was understood that they are linked with each other. They are part of same body. Okay, so how it can freely flow over one another? So to remove this confusion, at the same time, the same concept was used here, the horizontal movement of all these continental blocks or landmass on the Earth's surface. The same concept was modified through this plate tectonic theory. This was modified through plate tectonic theory. Now, plate. The word plate is used here with the meaning lithospheric plate. Now, in the interior of the earth, in that chapter, we learned about lithosphere. What was it?
Crust plus upper mantle.
Yes, it is crust plus upper mantle. Together, it will be called as lithosphere. Lithosphere means what? Crust plus upper mantle. So, according to this plate tectonic theory, plates which constitutes of irregularly shaped lithospheric slabs, which consist of irregularly shaped lithospheric slabs, and these slabs are freely floating over liquid asthenosphere. This is the main premise of this theory. These lithospheric plates are freely floating over liquid asthenosphere. So, in that particular diagram, we talked about asthenosphere. Okay, so it is there in mantle, upper mantle part. Okay, so asthenosphere, this is liquid. Why it was liquid?
Radioactivity.
Yes, there is heat produced in that region because of radioactive decay of elements, radioactive elements, and because of that, the severe amount of heat is being created. Whatever the matter that is there, rocks, all these are melted there, and it is source of magma. Okay, so in convection current theory, we learn about how this magma is flowing in a circular manner, cyclic manner. Okay, in a cyclic manner. Now, these lithospheric plates are basically floating over that asthenosphere, and the underlying convection currents are basically the force responsible for movement of these plates in a particular direction. Suppose the underlying convection current is moving in this direction. What will happen to this plate? It will also drifted towards in this direction because of this underlying current. Okay, so the force responsible, as explained by, basically this theory is given in 1967 by 3 geographers independently. Okay, Mackenzie, Morgan, and who is the third one?
Parker.
Okay, Parker. Okay, they have given independently, but it is same theory given by all three in 1967. The force responsible is convection current theory. Okay, so the convection currents of magma flowing through in asthenosphere, they are the force responsible for movement of these lithospheric plates. Now, this overcomes this continental drift theory, the limitations of continental drift theory. Okay, so the force given by continental drift theory was inadequate. This force is adequate now. Along with that, the formation of mountains is explained by the plate tectonic theory in a very, we can say, elaborate manner, and also the explanation is related to all types of mountains, be it fold mountains, fault mountains, or volcanic mountains. Okay, so this is important. Plate tectonic theory explains the distribution of volcanoes, distribution of earthquakes. Along with that, it also explains the mountain building theory. Okay, now according to PTT, how the continents move throughout the history, we should also know about this. This is given in NCERT. Okay, so what CDT, continental drift theory, had said, Pangea was there before 200 million years ago, but it was not able to explain what was before 200 million years ago. This was limitation. Then PTT explains before 200 million years ago also what happened. So according to plate tectonic theory, all these continents or simply these lithospheric plates randomly placed on the earth's surface. Okay, randomly placed on the earth's surface, and you can see that they started coming together 540 million years ago. They were randomly placed. Then 420 million. Then you can see 300 million. So they are coming together, and you can see that between 200 to 120, basically they came together to form Pangea. Pangea was there, but this supercontinent was formed because of coming together of all these lithospheric blocks. And later, after 200 million years ago, it broke into Laurasia and Gondwana land. And then all the continents started separating. Okay, or lithospheric plates. Now here onwards we will use the word lithospheric plates because we are learning plate tectonic theory now. Okay, so you can see the present day distribution of these lithospheric plates. Now, according to this plate tectonic theory, there are total 7 major plates. There are total 7 major plates and several minor plates. Which are these? We should know the names of major plates. Okay, so let's identify them. Okay, so yes, numbering already given. Antarctic plate, first one. Then second one, North American plate. Third one, South American plate. Okay, then fourth one, Pacific plate. Then yes, Indo-Australian plate, fifth one. Then there is African plate, sixth one, and seventh one is Eurasian plate. उसका पार्ट यहाँ पे भी दिखा है, यहाँ पे भी दिखा है ना? ये फ्लैट है, अर्थ इज ग्लोब, right? So these are 7 such major plates. Here onwards you should keep this in mind because we are going to learn mountain building theories or mountain building activities, formation of Himalayas, Alps, Rockies and Andes mountains. Along with that we are going to learn about formation of festoons and island archipelagos, island arcs, like ये Japanese arc कैसे बनता है, Philippines islands, Indonesian islands, then here the Caribbean island, how they are formed. There I will use the names of these plates. You should remember them. Some of the minor plates are also there. For example, see here the San Andreas Fault. We will talk about that. So it is located between Cocos Plate and North American Plate. Then there is Nazca Plate between South American Plate and Pacific Plate. है ना, ये भी जो है पैसिफिक प्लेट और नॉर्थ अमेरिकन प्लेट के बीच में है. It is Cocos Plate. Then there is Caribbean Plate also. There is one small Philippine Plate. We will talk about this while explaining Philippine Islands formation. Okay, so these are small plates and there are several in number. Okay, size में वो छोटे हैं. Fine. So what we have to remember is major plates. 7 major plates. Now there is one explanation on how Indian plate moved towards the present day location. ठीक है, तो NCERT में आपको वो डायग्राम भी दिया हुआ है. So Look at this photograph. So 70 million years ago, Indian peninsula started separating from the Madagascar and Antarctic plate. They were attached together or they were linked together. So from that location, that is beyond the Tropic of Capricorn in the southern hemisphere, it started drifting from that place, then it crossed the equator and the present day situation. And all this happened since 70 million years ago. And this also led to other several, we can say, geological phenomenon during this time. This movement has led to formation of Himalayas. The movement of Indian plate, we'll say, when I say Indian plate, it is Indian peninsula. It is Indian peninsula. And it moved in this direction, and being the oceanic plate, Indo-Australian plate, it subducted under Eurasian plate and there was formation of Himalayas. We are separately going to learn about formation of Himalayas. But you should know how Indian peninsula drifted. दिख रहा है ये? Indian peninsula shape?
ये drifting भी tectonic movements की वजह से?
Yes, it is because of convection currents underlying it. ठीक है, तो नीचे डायरेक्शन वैसा होगा, इसलिए वो वैसा मूव कर रहे हैं. Okay, so we should keep this in mind. The force responsible for movement of these lithospheric plates is convection currents, and this is final now. It is well established, it is accepted. Okay, so this was plate tectonic theory. Now according to plate tectonic theory, these plates, when they are moving freely on the earth's surface, there will be interaction of these plates with each other, and because of that various types of boundaries are formed. We are going to learn about this types of boundaries, as many of the tectonic activities happens along the boundaries of these plates. That's why it is important to learn about them, and we will compare them also with each other. So first one is, we can say, divergent plate boundary. Second one, convergent and third one, transform plate boundary. Okay, so let's see how they look like first. Okay, I will draw simple diagrams. Suppose this is the plate, one plate, this is the other plate. And divergent plate boundaries means basically they are diverging from each other. So there will be opposite forces acting on these two. So one is moving in this direction, other is moving in this direction. This boundary between these two will be called as divergent plate boundary. If we draw this one, convergent plate boundary. So if we draw like this, two plates. So convergent means they are coming together. So their movement will be towards each other. Their movements will be towards each other, and this interface is convergent plate boundary, right? And the third one is transform plate boundary. So suppose these are two plates, then one is moving in this direction, other is, so they are sliding past each other. The movement is tangential movement. The movement is tangential movement. That will be called as transform plate boundary. Okay, so this is how the movement you should know. Now this particular boundary is also called as, we can say, constructive plate boundary. Constructive. Why constructive? What happens at mid-oceanic ridge region?
Volcanic eruptions, mountain formation.
Yes, online students, you also give answers from time to time. What happens when let's say there is mid-oceanic ridge region. In the previous lecture we learned about this.
The lava erupts and formation of rock happens.
Yes, so lava eruption, or simply we can say that there is continuous volcanic eruption and new crust is being formed. That's why the word constructive. New crust is being formed. That's why the word constructive. So all these, let's say, areas of mid-oceanic ridges are basically the divergent plate boundaries. They are basically divergent plate boundaries. I will write here mid-oceanic ridge. These are the areas. Now this particular boundary is called as destructive plate boundary. Why destructive? Because
Subduction of plates happens.
yes, the older crust is getting consumed in the trench area where the subduction zone is there. So the heavier plate is subducting down the lighter plate. Okay, so when there is convergence, no, suppose this plate is heavier, this will go down like this. As this is denser, heavier, it will go down like this. And here there will be consumption of the older crust, destruction of the older crust, and that's why we are saying it is destructive plate march. समझ रहा है ना सबको? Yes? हाँ. What happens here in transform plate boundary? In transform plate boundary, basically there is no destruction or construction of crust. There is no destruction or formation of crust. When I say crust, what is it? Rocks. पहले ही आपको लेक्चर में बताया हुआ है, ठीक है. Crust means we say it is geographical term for rocks, okay, but it is larger term we can say. Now in transform boundary there is no consumption or destruction of the crust or formation of new crust. What is happening here, simply you can see, suppose these are two plates, lithospheric plates. In convergent these plates were moving in opposite direction. In divergent they were moving towards each other and heavier one was subducting like this. Now in transform what happens is it is just moving in opposite direction in tangential manner. See here. तो यहाँ पे क्या हो रहा है, कुछ भी टूट फूट नहीं रहा है, कुछ नया बन नहीं रहा है. So basically it is just, we can say, moving past each other. It is moving past each other. It is not resulting into construction or destruction activity in transform. Understood?
You can say that earthquake could happen because of that.
Yes, earthquake would happen here. Why? Because it is also tectonic activity. The lithospheric plates are moving, and when they are moving there can be imbalance of rocks, there can be release of energy. There can be release of energy, but again we can say that they will have shallow focus. Shallow focus earthquake. These will have deep focus earthquake. In trench region. These will have shallow focus earthquake. Then volcanic activities. Here also we can say extensive volcanic activity. And here comparatively lesser volcanic activities. Okay, so in this manner we should understand the difference between these boundaries, and here onwards when we learn about the distribution of volcanoes, earthquakes, so you will understand how the learning about or understanding about these plate boundaries is important. The example here, you should know the examples, like these are basically trench areas. Like here we have mentioned mid-oceanic ridge areas, and these are basically faults. These are faults. Understood? Everyone? प्लेट टेक्टोनिक थ्योरी समझ में आया आपको? Yes. Any question you are having related to plate tectonic theory? Yes. Okay. If you have understood this, yes, tell me.
Can we say that the divergent plate boundaries are dependent upon convergent or convergent are dependent upon divergent?
We will not say dependent upon. See, both are separate boundaries. Both are separate boundaries. You should know that lithospheric plate is made up of both continental crust and oceanic crust. It is not purely continental crust or oceanic crust. Each and every lithospheric plate is made up of both oceanic crust and continental crust. But on the basis of larger area covered by continent or oceanic crust, the plate will be called as continental plate or oceanic plate. For example, Pacific plate is largely covered by oceanic crust. That's why it will be called as oceanic plate. But if we take the example of Eurasian plate or African plate, largely continental mass is there. So that's why it will be called as continental plate. Now, within this convergence, there will be different three types of convergence, because there can be continental convergence, there can be oceanic convergence, and there can be continental oceanic convergence. Different types of plates will converge, leading to different types of landforms and processes. Okay, so that's why again in detail we have to learn about them. Okay, what is happening at mid-oceanic ridge? These plates are separating from each other. That's why we are saying it is divergent plate margin or boundary. Okay, at mid-oceanic ridge region, in sea floor spreading hypothesis, what we have learned, there is movement away from mid-oceanic ridge. Okay, so from this we are able to understand that South American plate and African plates, they are moving away from each other from this mid-Atlantic Ocean region. Again I am repeating, South American plate and African plate, they are moving away from each other, where? From mid-Atlantic ridge region. So there these are divergent. Okay, but if I take the example of South American plate and Pacific Ocean plate or oceanic plate, they are converging. Okay, and Pacific plate being the denser one, heavier one, is subducting below the South American plate. Understood? We will understand again in detail about these three types of convergence. Yes.
Sir, there is no formation or no destruction with the transformer.
Yes.
So where is this energy getting invested?
Where?
Is this energy getting invested?
Energy getting?
Still, the movement of the plate may cause energy formation. Like there must be some energy. Am I right?
Okay, movement. Same. See, force is same. Again I am repeating, the movement of these plates are also happening because of convection current. Just the direction of current underlying these plates is exactly opposite direction. That's why they are moving past each other, not towards or away from each other.
He is asking, जो ये movement हो रही है उसकी energy कहाँ जा रही है?
Energy कहाँ जा रही है?
अगर कुछ बन
ये जो okay, 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 okay. Yes, 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 yes. So understand here that if they are moving past each other, there will be redistribution of energy. Sometimes that is released as earthquake. Sometimes. The best example you can give, San Andreas Fault. उस पर एक मूवी आया था, इफ यू रिमेंबर, सैन एंड्रियास फॉल्ट, रॉक था ना उसमें, ठीक है, वो पहले याद आ जाता है हमें. हाँ, तो सैन एंड्रियास फॉल्ट, जस्ट नाउ वी हैव सीन इन द डायग्राम, इट इज लोकेटेड बिटवीन दैट Pacific plate, Cocos plate and North American plate. So along the western border or boundary of North America, this San Andreas Fault is located. There the small plate is sliding past the large plate. Okay, and because of that what happens, many a times the energy is released as earthquake. You should know that if the energy is released in at smaller scale, that does not always result into earthquake. Okay, so energy is continuously dissipating because of this movement. But if suppose sudden energy is released on large scale, then we can say earthquake happens. Then we can say earthquake happens. Okay, it depends on sudden movement, whether that movement is happening gradual manner or any sudden movement is happening. So if there is sudden movement, very large amount of energy is released. But when there is gradual movement, we can say that the energy release is dissipated and we do not know or we not understand also. Okay? Yes, Abhishek, understood? Okay, now the next part is 3 types of convergence. 3 types of convergence. First, continent ocean convergence. When I say continent ocean, means continental plate is converging with oceanic plate. Continental plate is converging with oceanic plate. Second, ocean convergence. And third, continent convergence. Continent convergence. Now continent ocean convergence. Continental plate is converging with oceanic plate. Example, Pacific plate and North American plate. So Pacific plate being the heavier, denser, will subduct under North American plate. I will show in diagram. This is oceanic convergence. Formation of Andes and Rockies. See, mountain formation simultaneously we have to learn. Okay, now how Rockies and Andes are formed? First of all, tell me the alignment of Rockies and Andes. North, south, east, west. North, south. Western margin, eastern margin.
Western margin.
Along the western margins of continents. Okay, so Rockies and Andes कहाँ है? Rockies Northern America, Andes in Southern America. I hope you have started reading atlas simultaneously. ठीक है, तो formation of Andes and Rockies are result of ocean continent convergence. How? Let's understand that. See here, this is the Pacific plate, and Pacific plate being the oceanic plate is subducting under the continental plate. Continental plate here for Rockies North American plate, for Andes it is South American plate. Okay.